can see the voltage reduced a little bit. It's still at 100 and something volts, and the light is still on. Guys, our generator is looking ready. We've already connected the voltmeter to check the voltage of the generator, of the current coming out from the alternator. We have our circuit breaker to turn it on and off. We have these are our two sockets we've connected, and the next thing we're going to connect is going to be this plug. So for now, I'll be connecting this plug to this bulb so that we can be able to plug it to the generator anytime we start it up. So that's what we're going to do right now. So guys, we're done with the connection. This one is the live, this one is the neutral, and this one is earth. So right now we have to put them together. Guys, you can see we are done with it. So what we're going to do right now is just to turn it on for some seconds and see if it's going to work. So guys, it worked. The two sockets are working perfectly well. So that's how we're going to be testing this, running the system right now. So guys, the moment you've all been waiting for, which is the chargeback system. So right now we have multiple transformers right here. We have about 5 transformers, and each of these transformer can output around 12 volts. So guys, 5 times 12, that will give us around 60 volts. You can see they are both connected to this rectifying diode. We have about 4 rectifying diode right here with multiple capacitors. So what we did was to connect them in series so that it will give us maximum output. The aim is to use high voltage architecture, so we're connecting them both in series so that we can get high voltage from each of the transformer. So guys, we're going to test the system and try to connect the charging system to it to see if it's going to charge back the battery. Remember guys, later on we're going to be changing this rectifying diode to a transistor. Transistor are fast switching components, fast switching devices. They can output high power, and it is called active rectification. That's what we're going to be using later on. So but for now, this is what we're going to be using. So guys, let's test the system and see if it's going to charge back the battery. So guys, one more thing, I've already connected the switch. So guys, we're going to be starting it up with the switch. Guys, we're going to be making another test. This is going to be the second test. can see the voltage reduced a little bit. It's still at 100 and something volts, and the light is still on. The battery is charging, and one way you would know is that the battery is a little bit warm. And the system is still running strong. You can see the voltage is still at 100 volts. That shows the battery is still charging and the light is still on. The voltage is not, it's only reduced a little bit, but it's still at 100 volts. That shows the battery is still charging and the light is still on. And if you see, it is still, the generator is still working very well with the same power. I noticed the rectifying diode are a little bit warm from the operation, but later on we're going to be using a DC fan to cool each one of them. You can see the light is still on. And the voltmeter is still at 100 volts, guys. The battery is charging. It's charging, guys. So guys, as you can see, the generator is still working and we are still at 100 volts. The generator has been running for up to like 5 minutes plus now. I can see the light is still on and the voltmeter still remains the same. I noticed the DC motor was even barely hot. It's not even hot at all, just a little bit warm. Why? Because of the fan cooling the DC motor. And the transformer is a little bit warm and the rectifying diode. I noticed the battery are a little bit warm also. You can see it's still running strong, still running very well. Let's check the voltage. Still at 100 volts and the light is still on, guys. So guys, let's turn it off. So guys, the test was successful. Normally this battery, it's not strong enough to power this system to be able to run up to 5 minutes. Even 1 minute it will kill the battery. But the generator was able to run for up to like 6 minutes plus. So that is to tell you that it was charging. So the first test we did, if you guys notice, you noticed the light dropped down. Why? It was because as a result of using all the multiple transformers, they dragged down the power down. So what I did was to just connect only this transformer and this one, these two. So I was running the system on 24 volts to charge this 12-volt battery. So you guys can see that why the generator was running. It was at first, when we started the test, it was at 220 volts, but later on it went to 100 volts, but it stayed at 100 volts for like up to 6 minutes plus. So that is to tell you that there's hope for the system, and we were also carrying load. If the bulb is even a little bit warm, it's now a little bit getting cold, but the system was able to run for a long time, for up to 6 minutes plus. I was the one who turned it off. If not, I know it's going to run even longer than that. And why I turned it off was because as a result of the battery is a little bit warm. The two battery are a little bit warm. That's why I turned it off. And you guys notice that these batteries are very, very small battery. The battery is not big enough. Imagine the battery was big enough, it would be able to charge even better. So these battery are little. This should be around 2 amp battery, joining them together. So that's why they are getting hot. So imagine the battery is a little bit bigger. Imagine using a UPS battery. It should be able to do the work perfectly well. And I was so surprised the system was able to maintain balance. And checking the DC motor, it's even barely hot. It's even barely hot. And the transformer is just a little bit warm. It's a little bit warm. And our rectifying diode is a little bit warm also too. So that is to tell you that what we're going to do later on is that we're going to be cooling the transformer, and we're going to be cooling the battery we're going to be using will be a little bit bigger battery, so that it will be able to charge. Because now what I've observed is that the battery gets a little bit warm when it's little or it's small. So guys, we're going to be perfecting the system as we go on. Okay, I'm going to be keeping you guys updated. This motor is even barely warm. So guys, as you guys can see, the system was able to run for a long time. It was able to run for 6 minutes plus, almost 7 minutes. Let's say 7 minutes, because normally anytime I try connecting this battery to the generator, it would not last even 1 minute. The system is going to switch off. It would not last 1 minute, but we're able to get up to 7 minutes of run time. That is an improvement, and that is to tell you that the system was charging. And you guys can notice that we're also checking the progress from the voltmeter. It still remain at this point for a long time, at 100 volts plus for a longer time. So that is to tell you that the system was charging very well. So guys, stay tuned for more updates. I'm going to be perfecting the system and making it a little bit easier to understand as possible. More updates coming your way next, guys. So guys, take care. And one thing I'm going to do, there's another thing I'm going to do. I'm going to connect it in a way that we're not just only going to be charging the battery, but the system is going to take over from this battery. So that's what we're going to be doing next, guys. So guys, stay tuned for more updates, and I'll see you guys on the next upload. Take care, guys.